everyone, and welcome to another Twitch show, The Routing Loop. It's Thursday, 10:30 a.m. Pacific. I am not good with time zones, so I don't know what other times are. I just know it's 10:30 Pacific or 1:30 p.m. Eastern. Thank you all for joining us. We have the Routing Loop every Thursday here on Twitch. We're really excited to have you with us today as we talk about a very fresh launch in VPC Lattice. And to talk about this, we have two awesome guests, Justin and Ryan. Guys, I'll let you introduce yourselves in a second. First, I'll go by saying that this will be our last Twitch stream before all the holiday season. We'll be back on February 1st. So in the meantime, if you want to do like a full recap of all we've done this year and all the sessions we've had every Thursday, please go to our webpage, The Routing Loop. I'll paste the link in the chat in a second. And check out all the past episodes. It will be a really fun thing for you folks to go back and see if you've missed anything, and let us know what you would love for the next year. We have there a feedback form, and we'd love to hear what your thoughts are. That said, I'm Alex. I'm one of the Twitch hosts for this show. You folks are probably familiar with me, Tom, Matt, and a bunch of other folks. And here's my cat, who today decided to also be a co-host on this show and is walking around my desk. Hopefully she doesn't stop the stream, but you never know. Let's keep our fingers crossed. Awesome. I already see a bunch of folks have joined us, so thank you so much. Please keep in mind, anytime, put your questions in the chat. We're here to answer them. We're here to make sure you make good use of this time and you get all the information that you need. That's it. Done. I talked too much. Ryan, Justin, go ahead and introduce yourselves. Let us know who you are and what you do.
Why don't you go for it, Ryan?
Sure. Okay. So my name is Ryan. I've been at Amazon for 5 years as of Monday. I had the pleasure of launching Lattice GA when it originally was available to the public. So since then, we've been iterating a bunch, and excited to put out this feature. I've been working on it for the past year, so finally happy to see it kind of come to everybody and they can enjoy it as much as I have over the last bit working on it.
That's awesome. Congratulations on the 5 years. I think that's why you still have the lanyard.
Yeah, it's fresh right now.
Nice. That's great. That's great. Congrats. And really excited to have you on the show. It's your first Twitch show, right?
Yes.
Okay, let's make sure it's not the last one. So we'd love to have you back. Not being sarcastic here, we'd love to have you back. Justin, go ahead.
Hey, folks. I probably know quite a few that usually are regular joiners here, but I'm Justin Davies. I'm one of the product managers in EC2 networking, and working alongside Ryan on VPC Lattice has been kind of our day-to-day activity for several years now. And so he's probably sick of me, but it's a great team, and we've been having fun over here, and this is an exciting year for us. So, yeah. Hi,
That's
everybody.
awesome. That's awesome. Justin, this is not your first Twitch show. You're an old friend of the Routing Loop here, so we're always excited to have you back talking about Lattice and all the cool stuff that you folks are working on. That's it. Without further ado, good afternoon, Ken. Thank you for joining us. Ken is a longstanding friend of the Routing Loop, and he's just been recently added to as an AWS hero. So congratulations, Ken, and really looking forward to seeing you at reInvent this year. Talking about reInvent, super quick nudge. If you folks haven't checked out the calendar yet, I doubt that you haven't, but we have really awesome sessions, and we still have some empty spots. check out Net 301, Advanced VPC Design and New Capabilities. We are in a big room this year, so we have a few open spots there for you folks, and we're going to be reviewing all new capabilities launched throughout 2024, including what we're going to be talking about today, but not only. We're still preparing some really cool things.
Alex? Where did they stick you? Usually you guys are the end of the last session after everything's gone, and it's still the most packed session, even considering keynotes. So when's your session this year?
So this year we're going to be on Monday evening. It's the first
that's
reInvent
good.
that
That's
we're
awesome.
not ending
Yeah.
reInvent. Reason for it is because you folks have done an amazing job on the service team sides to launch a lot of things before actually reInvent starts. This has
Cross
been
your
an
fingers.
exciting
We still
year.
got a couple that we're hoping for.
I trust me, I'm holding all my fingers crossed because I've built a bunch of slides, so I would really love to use those slides in the session. But yeah, this year we are on Monday evening, 5:30 p.m. in the Venetian showroom. So we have a big room. Looking forward to seeing you all folks there. And then after Monday, looking forward to peer talks and EBCs and sessions and meeting you all during lunches and breaks. So meet us there. That's it. Without further ado, today we're going to be talking about Amazon VPC Lattice built-in support for Amazon ECS. And since VPC Lattice launched, I know I've been talking to a bunch of customers about this feature and this built-in support. So I think, Justin, you're really excited that we launched this, right?
This is, I mean, I said it when I posted about it the other day, but this is one of our top requested features. We had a workaround for it, and so customers could do it, but it just wasn't ideal. Nobody wants to hear when they say, "Hey, is such and such supported?" They never want to hear you say, "Yeah, there's a workaround." They wanted to hear like "yes" and then move on. And so this was kind of one of those ones where it's like, it was a bummer, but we got it out, and it was our probably number 2 customer requested feature overall. And so we're pumped about having this support, and our customers are too. We've already seen a good intake, so it's been really nice and relaxing couple of days after that went through.
Got it. Your hair started growing back, right?
Yeah, it's I lost it at the very beginning of Lattice, and then like slowly but surely, at least the sides are starting to go a little faster.
Yeah. We have a question in the chat, and I think this is the perfect time to start with the super quick introduction on what VPC Lattice is. And before I give the mic to you, thank you, Programmer XYZ, for your question. And all of you, keep in mind, the chat is yours. So let us know if you have any questions, and we're happy to answer them. So before we jump right in, for everyone who's interested, we have a repost article that gathers all resources related to VPC Lattice. All new launches are at the top. All blogs, white papers, workshops, reference architectures are all in there to make it easy for you to get started with VPC Lattice. Now, Justin, what is VPC Lattice?
Sure. So it's really kind of a application layer load balancer, if you think about it. That connects all of your services across VPCs and accounts and is natively integrated in the various compute platforms in AWS. And so if you think about today, if you're running anything at Amazon at all, and it's not just an S3 bucket, you probably have at least some EC2 instances or some sort of compute where your application's running. And then you probably have either an API gateway or an ALB or an NLB sitting in front of these things, right? Which is handling all the load balancing to take advantage of all the kind of scale and horizontal scalability of a web service, right? On top of that, if you have applications across multiple VPCs, you probably have some sort of network connectivity between these VPCs as well. Something like a VPC peer, something like a transit gateway, Cloud WAN, private link. These are all different kinds of connectivity mechanisms. When which is great. These things solve the problem. You've got your application, you've got connectivity, you've got load balancing, right? What VPC Lattice came to the table with is just like, how can we make this stuff way simpler, right? Is there ways that we could kind of more deeply integrate with EKS and ECS and Lambda? And can we provide all that kind of features without making the customer be a networking expert? So that's kind of the mission that we set out to do, and that's kind of what VPC Lattice ended up doing. You can think of VPC Lattice as kind of this like fully managed little proxy that's invisible to you. It's fully managed. We take care of everything. You tell us what services you want to put in it, and then it'll automatically handle all the network connectivity and load balancing between your services across VPCs, across accounts, so on and so forth.
Is it the right time, Justin, to start drawing out a bit, maybe
Sure.
even at high level?
Yeah. Let me see here. I think my screen show up there.
Yep, we have you on the screen.
So here's what a very typical customer looks like. I don't talk to too many customers anymore that only have one VPC, which is so crazy if you rewind back time, because, we thought VPCs were going to be a data center, and how often do you come across a customer that even has their own data center? And so what that typically looks like, though, is you probably have, app 1, app 2, and app 3. A very common portfolio kind of pattern is to basically say, I'm going to spin up an account or NVPCs and kind of give them out to app teams. And these could be 3-tier web apps. These could be more complex than that, but it's usually consisting of applications and databases and all that kind of stuff. But you can think of these as kind of like HTTP endpoints, right? A DNS endpoint or something like that. Before, you used to have to do the load balancers here. Let's say that's an ALB. You'd put an ALB here, and then you put an ALB here, right? And then you'd have to do the network connectivity piece as well, right? Something like a TGW or VPC peering or something like that. What Lattice does is it combines the functionality of these load balancers and the network connectivity in a much simpler kind of approach. And so if I erase all those, let's see here. And I just create a kind of load balancer out here, and I'll call this, let's just call this Lattice for right now. I can go and register my services. And so we have a service directory where I can say A1, A2, A3. And I can basically share these across and connect connectivity by spinning up connectivity here. And so all of your clients will actually go and connect to Lattice. Lattice will do all the HTTP termination, look at the headers, figure out where it actually needs to go, and then it'll distribute the traffic down to the actual backends so that you don't have to manage the load balancer, don't have to manage updating route table entries or anything like that.
That's awesome. Okay, so this is Lattice. Lattice comes with a couple of constructs. I think it's important for us to maybe at least define them at very high level, given that we already have the diagram here. So do you want to tell us a bit about the service network and associations?
Sure. So right here, we just talked about the first piece of it right here. If I draw this box, this is what we call the service directory. I'll just put SD for short. This is just basically a big, huge list that's per account that tells you all of the services that you've created or all the services that were shared with you via a different account or something like that. So this is basically, the admins love it because it's one place to see what the heck does this account have access to. The developer loves it because they can just go to this service directory and basically copy and paste the DNS endpoint and put it in their app to basically call it. Okay, so that's the service directory, and that's kind of a pretty core fundamental piece of VPC Lattice. The next piece that I would say is the service itself, right? So I've said this term a couple of times, a VPC Lattice service, but what does that mean, right? Because you might call it an app, you might call it a front end, you might call it an API. But in VPC Lattice world, a service, let me say service equals a combination of listeners, rules, and target groups. Okay, very similar
like
to a load balancer.
Like a load balancer. Yeah, that's what I was
Just like
about
it.
to say.
Yeah, we're a creature of habit. So this is a term that a lot of customers are familiar with, and so it kind of models what you think of as an application today anyway, right? Listener is things like, am I looking for port 80? Is it an HTTP service? Is it an HTTPS service? Is it a TLS service? And so this is kind of like, what should Lattice listen for when you send this connection? Okay. So in most cases, what you probably see, I'd say probably 98% of the time, it's going to be an HTTPS service. Okay. So you'd say HTTPS for the listener. The rule might be something like just default forward. Anything that comes in here, forward it. Or it can be way more advanced, right? You could do stuff like if the header equals user agent equals Ryan, or query string parameter equals blah, 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 or the method equals a GET request. You can do all kinds of cool rules based on HTTP and application layer constructs in the headers. And so once you define that rule, you say what you want to do with it, right? You might have a Lambda function that's going and handling all your GET requests, okay? And you might have on ECS all the things that are happening in your put requests. And on, I probably said these backwards, but EKS, ECS, EC2, auto-scaling groups, IP targets, whatever you want to do there. Now we support them all. Originally, you had to put an ALB in front of your ECS target. But now, you can put them in front of any of them. And you can divide this traffic based on rules, however you see fit. And so the service might be something like myservice.com. And then behind the scenes, you tell me what you want that to do. Well, I want HTTPS, header equals user agent equals Ryan. Send that to Lambda. If it's something else, send it to ECS. Something else, send it to Kubernetes. And so this gives you that kind of very flexible approach. And you can even do it across different VPCs. You might have the GET request in the Lambda function, not even in a VPC. You might have the ECS service handling your put requests, and that's in VPC 1. And likewise, you have an EKS cluster that's doing something different. So it gives you this really cool way of kind of modeling a service, what we think of as a service, and sharing that around. And so that's a VPC Lattice service. Okay.
So we have the service directory, we have a service, and before we get to the service network piece, we have a quick question. Is VPC Lattice available in AWS GovCloud
Not yet.
regions?
Not yet. We've got most of the commercial regions, but we're not in GovCloud yet.
Getting there.
Yeah.
Okay, cool. So service directory, services, and the last thing that brings services and clients together, I guess.
Yeah, and so we needed a way to kind of like share a bunch of things because, in modern environments, it's not just like one thing talking to one thing. It's much more complex than that usually. And you've got, maybe I've got a bunch of shared services that I want to talk to, or, I've got a whole section of an application that has several APIs that they want to share with me and things like that. And so we wanted to create this grouping mechanism that customers could use to kind of share things around and enable connectivity a little bit easier. And so we invented this thing. It's just a logical thing. It's not a physical thing. It's nothing more than just a grouping mechanism. And we call it a service network. And this service network allows you to kind of model however you want to set up app 1, app 2, app 3, app 4. And then instead of sharing each one of those individual apps with all of your different VPCs and clients, it allows you to model it once. And then if you have VPC 1, VPC 2, VPC 3, I can associate it to these different VPCs. Okay? And when I associate this service network with these VPCs, it enables connectivity to everything in these VPCs, right? So this client in this VPC now has access to all of these. Okay, so very simple approach to kind of enable that kind of connectivity. Of course, there's ways to lock this down further, and there's ways to kind of make this even more secure, or say only specific resources in the VPC have access. You can enable authentication and authorization. These are all features. But the simplest case is and where most customers start is just like, hey, I just want a very simple connectivity mechanism that allows me to not deal with IP addresses. And this is kind of that approach.
Awesome. Okay, cool. So, long story short, this is VPC Lattice. We have added to the chat the Get Started guide. I'm going to add it again just so you folks have it and get all the resources there. We have another question. How does it do load balancing if we don't have a load balancer?
Yeah, so VPC Lattice is a load balancer. So it is basically behind the scenes. We're a big load balancer. So just like the same way that an ALB is a load balancer, right? Lattice is a load balancer. And every single service in Lattice, you could think of it as a micro little load balancer that you just don't see. And so it also happens to have logical Ethernet cables that plug into your VPCs. Okay? And so when you make a request from one VPC to Lattice, Lattice goes and terminates TLS for you, looks at the rules that you have, and you might have a header that says, just decrypt and send the traffic over to my backend, right? Whatever the service it is trying to get to. Lattice will then go and do the load balancing at the target group level, right? And just send the traffic weighted round robin to all your backend services. You can also configure things like, let's say you're doing some sort of blue-green deployment. And this can be across VPCs. It doesn't have to be in the same VPC. But let's say this is service 1, and you've got either a canary rollout or you've got blue-green deployment of some sort. You can actually even configure Lattice to say send 10% to green, keep 90% on blue, verify the traffic's up and running, look at your errors, look at your logs. And then once you're good, you can actually delete this target group and shift 100% over here. And so Lattice itself, each service is technically a load balancer.
Cool. Okay, awesome. Now let's talk a bit about the ECS built-in support for Lattice. You mentioned, Justin, that we used to support ECS with an application load balancer in front of it, but now we don't need that anymore. So do you want to show a bit how it was before, and just make sure you put there on the left side how it used to be?
Yeah, so maybe I'll draw a line and say old
before.
way, new way.
Big red X through it or something like.
Yeah, let's see here. I can do. No, this would be new way, and this would be old way.
There you go.
Yep.
Does that work? That's to the extent of my notability skills. Alex is really good at this.
I'm looking at you and I'm like, I would do that line a bit differently.
I wish I was doing this. Gladly give
It's all good. It's all good. It's a learning process, Justin.
All right, so let's draw an example. This can all be in the same VPC too. I don't want you to think that it's just across VPCs. I just usually draw it across VPCs because it's probably one of the most powerful features Lattice offers. And a lot of the time, kind of the bigger the customer gets, typically they're not dealing with one VPC. They're dealing with more and more VPCs, and they're trying to kind of isolate those VPCs into smaller components just to make security simpler, right? And so what I usually draw is I've got a client here. This is an HTTP client. It can also be a service, right? That has a dependency on something else. Let's draw another VPC here. And let's say it's in an ECS cluster. And this is an ECS cluster. And these are tasks of an ECS service. Okay. So similar to Kubernetes, if you're not familiar, it's in layers, right? You have a Kubernetes cluster, and then inside the Kubernetes cluster, you have a service, and those services are fed by pods. It's the same thing kind of for ECS. You have an ECS cluster where you host everything, and then you define a service. This can be an HTTP endpoint or something like that. And then that service is powered by tasks, okay? And that task can be a collection of containers, right? It can be several containers. It can be one container. It doesn't matter. It's just a collection. And so they're both very similar when you think about it from a Kubernetes perspective or a ECS perspective. But in the past, the most common method to access these tasks was to put an ALB or an NLB. So depending on if you needed L7 connectivity or L4 connectivity, in front of this ECS cluster. And there was native integration between these ALBs and NLBs so that as a service spun up and spun down tasks, it would automatically register. And so your clients, through something like a transit gateway, say a TGW, would go through and they would connect to a singular endpoint, which is this ALB's front end. And then the ALB would go and load balance you among the targets, okay? And that was how people did it for years. When we launched VPC Lattice, we basically had native integration with all the compute platforms. ECS, we had to use a workaround to start. And what that looked like was that we had to keep, instead of doing a TGW, you would basically have a Lattice service network still, and then you'd have a service, and that service would have an ALB as its target. Okay, so what customers were doing was basically saying, okay, well, I'm not going to change any of my back-end architecture here, keep that the same. What I'm going to do is just basically go and create beside it a VPC Lattice service, listeners HTTPS, rule is default forward, and the target group is not the task, it's the ALB. Mm-hmm. And so it was a very quick way for customers to just say, I can take my existing architecture and just put it there.
So it was like putting an ALB in front of an ALB or an NLB in front of an ALB, right, essentially.
Yep. Yeah, it's basically a proxy in front of a proxy, which from a latency perspective, it's not a huge hit. These are very optimal performance devices. It's still kind of one of those things like, do I really want two things in front? No, of course not. But a lot of customers liked the advantage of the simplicity and some of the security features and logging features that Lattice liked. And so for them, it was an advantage to say, let's do it. So what's the new way? It's a pretty boring feature. It's nothing special. It's just now, let me see. Okay, this is going to be to my extent of
my, select and copy.
Do I duplicate?
Duplicate, okay. Yes.
Okay. This is now perfect. I'm entering the skill set of Alex 10 years ago. Okay. So no, that's not what I wanted to erase. Okay. So now what we're saying is you can get rid of this ALB, stop paying for it, stop having that extra hop, so on and so forth. And Lattice natively can register with those ECS tasks. So as the same way that your ALB was doing it before, Lattice does it too. And so when and we're going to show this, Ryan's going to kind of walk through the setup here in just a minute. But when you go and set this ECS service up, instead of selecting an ALB as the front, you basically pick Lattice, right? Oh, and you specify that setup there. And so it's nothing fancy. I just erased a couple of lines in the ALB. It's behind the scenes, it's drastically simpler.
I was going to say, it's pretty fancy behind the scenes, but at the forefront, it's very easy.
And that is the goal, right? That is 100% the goal, is to make this as simple as possible. We don't want it to look complex. That's the idea of a managed service.
Before we dive right in, and I think this is so exciting. I've gotten countless questions of when we're going to be supporting this, because customers are like, I don't want to maintain a load balancer in front of a load balancer. It's kind of costly as well and not optimized. So I'm personally super excited about this because I'll get to do that thing that you mentioned, Justin. I'll get to talk to customers and say, of course it is supported. But actually, one thing, there's nothing saying that I need to delete that NLB, right, to be able to integrate with Lattice. I can keep it. Maybe I have clients that are accessing that ALB from the internet, or I have clients that are accessing that ALB from, I don't know, my own premises infrastructure. I don't need to delete it to actually create this integration, right? They can work both in parallel.
Yep. Yeah, I drew it in the old one, but these can live side by side. And typically what I'll tell customers is like, you probably should have these side by side, at least for the interim of the migration, right?
Yeah.
It's so much easier to delete something and just keep running on your existing architecture than to fundamentally break it down and start something new. You don't need that crazy maintenance window to go and delete everything and change everything. You can keep this thing up and running, keep your ALB there. This ALB will still be used, right? Sorry for all the lines, but maybe you even have internet clients that are trying to access this. It's just DNS. And so if the DNS private hosted zone tells this client to go to Lattice, it'll go to Lattice. If the public hosted zone out on the internet or other private hosted zones in different VPCs are telling it to go to the ALB, it'll go to the ALB. And so there's nothing crazy there. It's just basic DNS saying, what IP do you want to go to? Right.
Perfect.
And that's kind of the major beauty of it. You can migrate these things over time and you can keep them living in perpetuity if this is kind of the architecture you want to do. But it allows you to kind of migrate simply over time.
Cool. I put in the chat for everyone here the link to the DNS migration strategies blog. Really, really easy, straightforward to do, depending on if you have public hosted zones or private hosted zones. At the end of the day, as Justin mentioned, is just a DNS update. And you can super easily roll back too. If you're like, I've moved to Lattice this service and I don't know, getting some error. You can go back on that DNS record, you can revert it, you can troubleshoot, and then do the migration without downtime. So really
there's a
easy
question on there.
Yep.
Don't know how to say it. Kritsi.co.
Yep.
I would point out on this one, different customers have different needs. These are both container platforms, right? And they're probably, I would say, managed at different layers. We're a big fan of both. And I would say that so many customers say it's all or nothing. And I really think it's just worthwhile saying, like, what level is the customer interested in and what pieces are they interested in? ECS is really simple. Like, it is probably the simplest way to run a container known to man, known to human. And so I wouldn't discount that. Now, with that being said, EKS is probably the most flexible platform you're ever going to come across. The consistency of API and those kind of things are just beautiful, right? And so it just depends on where the customer's at and kind of what level of interaction they want to have. So with that being said, though, one of the cool things about Lattice is that it makes that conversation with your customer super simple, right? Because if I drew that picture again, and I had the client here, and I have the service network and a service, right? And this could be myservice.com. And today, let's say it lives on an ECS service. Say that's ECS S1, and you've got task, 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 right? And that's in maybe one VPC. You could go and spin up an EKS cluster in a different VPC if you wanted, or same VPC, doesn't matter. And let's say that's the EKS cluster. And you define the service one, and these are pods instead of Ts. You could go ahead and do the exact same blue-green type thing we talked about before. These would just be different target groups. And then you could do the weighted routing to shift that over. And so you really could spin up an entirely new environment, and it should be completely seamless to this client. They wouldn't even know the difference. And so if you are going to go down that path and you're going to look at that kind of stuff, this will erase that conversation of it being too difficult. I would more just concentrate on what compute platform is best for whatever they're trying to do.
And that actually makes it easy. I think the conversation becomes easier because that focus is going to be now. Let's test blue green, and let's see the performance you're getting. Let's see how you manage this service. Let's see, does it give you what you want if you move to EKS? Not all things can be put on EKS. Not all things can be put in ECS. Not all things are Lambda ready. So yeah, it becomes a matter of just choosing the optimized compute solution without worrying that optimized compute solution means a super complex boil the ocean type thing of impacting the entire environment and the architecture, which is amazing. I love it.
It doesn't have to be all or nothing, right? Like,
Yeah.
well, I was talking to a very big bank last year at reInvent, and I remember, I'm in a world where we are talking about microservices and modern application architecture all the time. And so like I went in and I'm like, yeah, like you can connect all your microservices together. And basically the CTO of this big bank was like, look, I would love to sit here and tell you that I'm all microservices, but the fact of the matter is I'm probably 90% monoliths on EC2. And like, I would love to get there and I've got projects to get there, but it's going to be probably 10 years. And I just laughed because I was like, oh yeah, I'm probably talking to the wrong audience here. Like, this is the beauty of having something like Lattice. It's not a service mesh, right? Like we don't care what your compute platform is. We've integrated with all the different compute platforms so that you can make a consistent connectivity and security and routing story without having to be like, oh, well, only part of my workload is modern. It doesn't matter. Like all of this stuff looks the same. And that's the beauty of it, right? It's like, how do I make this consistent so that my application teams can migrate at their own pace and I don't have to have everyone move at the same time?
Awesome stuff. You could add there a target group 3 with the Lambda function so that you can show
that's
your
the
customer. You can show your customer and be like, hey, look, this is the performance you're getting on each. This is how your application works on each. You choose and see which one is optimized for you.
I will say it's also Fargate too. So Fargate works out of the box as well. This isn't like an ECS cluster only type thing or anything like that. It's ECS Fargate. You can do serverless, Lambda,
Justin,
Fargate,
I'm very sorry, but I don't think that you wrote Fargate there.
You can't see Fargate there?
No. But I can actually see his foobar.
Let's see here.
One thing that you talked about before too is across accounts and across VPCs. I don't know if you spoke too much about across accounts, but the sharing, maybe might be useful to touch on that because we'll demo that, but I think that's pretty powerful as well.
Yeah, so it depends where customers are in their journey, right? How they think about accounts and VPCs and things like that. But I would say as soon as you're at like a medium size type workload, accounts and VPCs, you should probably have more than one of them, both of them.
Absolutely.
And it really comes down to kind of network level controls and permissions level controls. When you have smaller things, your security policy and your network configuration becomes simpler. Simpler is also easier to understand. When you understand something, you're less likely to not be in a situation where you end up on Hacker News because it wasn't what you thought it was, right? So the idea of having smaller accounts, smaller VPCs, it gives you this kind of flexibility of kind of tighter controls. And so when we draw this up, when we kind of show, in all these examples that we're talking about, I've got app 1 here, app 2 here. So I get that I've spelled it differently every time I've done this. You can have these. I draw it out in VPCs, but these can be in different accounts too, right? Which is the beauty of this. And when you have your service directory there and you're looking at what you have access to, again, it's what you've created yourself and what has been shared with you through a platform called Resource Access Manager. And that actually allows you to share these things around and kind of tightly control them in different accounts, right? Which you might want to do for compliance reasons. This is another one. All the big banks, they definitely don't have one account and one VPC.
Yep, that's absolutely true, and it becomes or it's become already table stakes. Multi-account, multi-VPC is something that if you have a single account and a single VPC where you've put all your workloads, you are probably having a pretty hard time understanding who gets access to what, like what are the permissions in those IAM roles that you have in that account. Like it's pretty tough to grok like this big massive thing. So +1 to splitting it.
The other part I would say, and it makes more sense when you start to actually use it, and I think it'll make more sense when we go in the demo to see kind of how we think about accounts and sharing. But in Resource Access Manager, it allows you to share what's called resources. And in Lattice world, these are service networks and services. And again, if you remember at the beginning of the talk, we talked about what a service is. And it's listeners, rules, and targets. And it's an abstraction that can sit in front of your actual apps or workloads or batch jobs or whatever the heck you have. But you're able to actually share both of those, right? You can share a whole service network that's already been outfitted with your different apps in it, or you can share individual services. If maybe your consumer has their own service network and they want to design it and make it however they see fit.
Awesome. Before we move forward, let's do a small recap for everyone who's joined us a bit later. We're here joined by Justin, who's a product manager for VPC Lattice, and Ryan, who's been building VPC Lattice since the beginning and has worked on this new feature we're talking about today, which is VPC Lattice built-in support for Amazon ECS. We are talking about a lot of things though in the Lattice world here, and this is great. We love your questions in the chat. Please do add more questions. Let us know if you're interested in any details around the feature launch. And we're slowly getting into the demo, which I'm really excited about because it will involve Ryan here configuring 2 ECS services, one on EC2 and one on Fargate, and shared them with my account, and I'll try to test them and see how things go. So yes, let's see how that goes.
Cool.
Awesome. So folks in the chat, do you have any questions? Let us know. If you don't, we're gonna get to the demo part. Ryan, are you ready to share a screen? Are you logged in? Do you want to refresh your page maybe?
Yes. I make sure I still have creds here. Yes.
Default.
We are good.
Wonderful. Okay, let's do this. Let me get your screen up here. So what do we have here?
Cool. So maybe take a step back here. So I've set up 2 clusters beforehand. One of them.
Sorry for interrupting. Can
Yes.
you do Command plus 1 or 2 times
Yes.
to make the screen bigger? Perfect. This is great.
Okay.
I think it's
Cool.
good now. Yep.
Okay. So I'm in the ECS console right now, and I've set up 2 clusters. So one of the clusters is running on an EC2, and one of the clusters is running with Fargate. So these are the compute types that are backing each of these clusters. So what I'm going to demo is creating a new ECS service within each of these clusters. One of the services will obviously run on EC2, and the other will run on Fargate. Both of them are set to scale up and down based on the number of tasks that are required. So for this demo, we'll just do one, but as your scaling requirements change, they will scale dynamically with the number of targets that will be associated with Lattice. So that might be something to touch on as well.
Yes, that's exactly what I wanted to ask. Do I need to do anything, or will you need to do anything when the task scales? Like, do you need to add more IPs to the target group, or everything is automated and nice?
All of that is automated and nice. I'd say it's slightly easier on Fargate. In EC2, you just have to make sure you have the right capacity and right instances. That kind of goes without saying. That's how ECS works today. But as long as you have defined the capacity to be large enough, we will scale up to whatever you set our limits at.
Awesome stuff.
Cool. So as part of this flow, you can, again, I said I'm creating new services. You can take existing ECS services and also add Lattice support. Whatever fits your needs. So maybe let's start with EC2 here. So right now, this is the cluster. I don't have any services in it. You can see I do have one container instance running here that will host the task that I'm about to launch. So, and please interrupt me if you have any questions along the way.
One quick question. So you pre-created this cluster. We're assuming that if you folks watching us are following this along, you have an ECS cluster, one that's based on EC2 and one that's on Fargate. If you don't have these already created, what you can do is you can watch us do it now. All of this is recorded, and you can come back to the Twitch recording and follow along again step by step if you are in the meantime creating your ECS clusters. So don't worry, all we're doing here is recorded, and you can come back to it later. Cool stuff. Okay, so we have a cluster. We don't have any service. Did you already define like a task definition, like I don't know, something that responds to my curls with a hello world or something?
Yeah, so that was my next point. I have created a task definition for each of these services as well. So it's just a simple web server that responds on port 80, just with, hey, I'm from Fargate, or hey, I'm from EC2. So when you call it later, you can confirm that it's hitting the right targets, or right ECS tasks in this case. Again, these are concepts pre-existing to ECS, but still important to be mindful of when you're setting this up with Lattice. Awesome. Okay. So we can create a service here. So because we are using the EC2 cluster, we're just going to use the existing cluster default strategy provider. So this is the provider that will run on the EC2 instance I showed you earlier. For a task definition, we're going to use the EC2 task definition here. So this is the one I just spoke about that will respond on port 80. For a service name, we can just do EC2 Lattice.
Does this service name have to be the same as the service name that we'll be configuring in Lattice?
No, they're completely unique.
Oh, okay. So it doesn't matter. This is a relevant service name only for ECS, essentially.
Correct. Yes.
Okay. Cool.
And again, yeah, important as well, because if you are updating an existing service, there's chances are they probably aren't going to match what you have for your Lattice service anyways.
Cool.
Okay, we'll just create one task here. And if we scroll down, you'll see this new option for VPC Lattice. So we will turn on VPC Lattice here. So as part of this integration, you provide a role to Lattice. So this is a role that Lattice will use to make, or Lattice will assume to manage your service on your behalf. So this role needs to have the correct permissions to actually do this management. So I've created this earlier, but I can show you it in my console as well, maybe just for everyone's own understanding. Apparently the zoom doesn't stay on every page here.
No.
Okay, so this is the role I'll be using. ECS infrastructure role, VPC Lattice. We've made it easy for you.
Did you name it? Did
Yes.
you create it? Okay, so I can put any name I want there, right?
You can put whatever name you want. Yeah, you can put something maybe more exciting than this boring one I've got.
You can see that you're an SDE on VPC Lattice because you're actually using the naming convention, and I thought it was actually I thought it was actually a managed role because these are the names of managed roles.
Yeah, it's bleeding into my life. It's camel case everywhere.
Nice.
Cool. Yeah, so this is a role you create yourself. You're welcome to put whatever permissions on it you'd like as well, although what we recommend is to use the new manage policy. So this is this one right here. It's an infrastructure role for VPC Lattice with ECS. So you'll see the minimum permissions that are required for this integration. And attaching that will give VPC Lattice all the access it needs to register, deregister tasks on your behalf.
I want to reemphasize what Ryan's saying there is like, you could make this anything you want. It's just the advice would be only use this role for just this activity, for just this thing, and don't add anything to the managed policy because that's the least privileged way. And you really don't want to be reusing these broad roles for different actions, right?
Please don't use admin. I know it's easy, but don't use it.
The policy there is already created for you. So you just have to create the role and then put that policy. So
Correct.
Cool.
This is also a concept that's pre-existing in ECS world. So they do have a concept of infrastructure roles already. They're used, I think, for their EBS integration as well. So you may already have one of these, but you are welcome to add this policy to it, or like Justin's suggesting, using a brand new one is probably the better way to do it anyways.
Back to that granular control of what every role can do in every account. Really important.
Cool. So here we get a nice drop down of some available roles. We're going to use the role I just showed you, VPC. So in SFO right now, I just have the one VPC. So we will select this one. It's also, if you've used Lattice before, there are some security groups related to this VPC. You'll need to make sure that these security groups have Lattice added as the prefix list. So Lattice traffic is allowed in on the security groups. Otherwise, you won't be able to reach any of your instances or reach any of your tasks.
Is this VPC the VPC where you deployed your ECS cluster, essentially?
Yes, it's the same VPC.
Perfect. So not another different VPC. You just have to tell Lattice what is the VPC where your ECS cluster lives.
Exactly.
Okay, cool.
Okay, so target groups here. We are going to create a new target group for this. So as part of this flow, I don't need to have one at all, but we'll create one as part of this demo. So let's do EC2 Lattice. Again, this can be named whatever you want. Port name. So this port name is populated based on the port mappings that are in your task definition. So I only have one port name available. That's test VPC Lattice, hence the only one that's available to me.
Cool.
And we will accept traffic on port 80 just with HTTP.
If, for
so you'll see here.
One quick question. If, for example, I had here more port mappings, I could have done, like I could have added more target groups and match all those port mappings, or it's in the same target group, all the port mappings?
So each target group will have one unique port mapping, but you could have up to 5 different target groups.
Perfect.
So depending on your needs, you can register these tasks with multiple target groups. Again, we'll keep it simple for now and just use the one. You'll see a call out here that it's going to create new target groups, but there's no listener actually attached. So this is the concept of how we're going to actually get traffic to those target groups. We'll connect that afterwards. So from here, that's it. So we're going to click create at the bottom, and ECS will go about starting up this task. So if we give it a minute or two here, you'll see the service will start to show up in here. We can also monitor our VPC Lattice console to see these target groups being created.
Okay, perfect. So, it's already active. Nice.
Yes, so there's one here. Tasks probably aren't quite there yet. They'll be here in a minute or so.
That's great.
So, again,
so just to recap, while all of this is happening, what we've done is we went into our ECS cluster. We created a new ECS service. We already had a task definition. And for that ECS service, we turned on VPC Lattice, which is actually creating a target group that's fully managed with the IP addresses of your ECS tasks. Does that sound right?
Yes.
Cool. I think this is perfect because you and I, Ryan, on this Twitch live, we are actually mapping the personas that Lattice addresses. I'm the networking person that has no clue about what you're doing here. What is ECS? Like, funny thing, we did this test when we were I was testing the ECS integration a couple of days ago before we launched. and I deployed my first ECS cluster in my account, and I was like, dude, I don't know what this is. Like, I don't need to. This is the amazing part. Jokes aside, Ryan knows what he needs to do here with his services and his task definitions and his ECS clusters. And I don't need to know about that. You folks will see that will be so easy for me. I'll just take the services that are shared with me, add them to the service network, and curl them. That's all I need to know. This is great.
Cool. So the next page here, you can see there's a task that's been registered with this target group. So this is our ECS task. But you'll see it's unused. So right now, this is health check, or health status, I should say. It's not associated with a service right now. So let's do that. Then we can see the health check start passing, and we can start getting some traffic to it. So let's go to the services tab here. So I pre-created these services as well. So for this one, we'll use the EC2 demo. This one has a default domain name that we'll talk about later. It doesn't have any listeners or anything else special on it though. So now we'll add a listener. So this is what will actually define traffic getting to the target group we just created. We told our target group to accept traffic on port 80. So we are going to configure this listener to port 80. We are going to use the default listener action and forward everything to our target group we just created. So 100% will go to this new EC2 Lattice target group. One thing I should call out, if you are creating these manually or not through the console, you'll want to create your target group as a target group type of IP. So this is an existing target group type we already support, but if you're looking to connect it back to ECS, it will need to be IP target group type.
I think one clarification is in order here, because I've seen this a lot with a lot of customers. The moment when they see target group type IP, there's an initial association that they need to configure static IPs in the target group because that is not automatically updated. To reiterate, target type is IP target type, but you don't need to go there and specify every single IP of your tasks.
Correct.
Ryan did that
the integration
work behind the scenes for you.
Yes. Many long hours doing that for you.
That's amazing. Thank you, Ryan. We appreciate
it. Okay, so we'll add this listener here. Okay, so we successfully created the listener to that target group. If we go back to this target group, cool, it's healthy. So that's quick. So now we can see, yes, target group is registered with the service and it's available to accept traffic. Cool thing about the health statuses too, you may be asking this, the ECS integrates with Lattice health statuses, and as well as ECS health statuses. So if you have container health checks set up on your ECS tasks, in addition or to Lattice health checks, if any of them become unhealthy, ECS will automatically deregister the task and restart up a new one. So you can kind of rest assured if something's broken in the chain there, ECS will replace it and we'll get it back up and running.
Awesome. You read my mind, Ryan, with the first question. The second question, though, is I would ask you one thing for everyone who's watching us now, and because you have two tabs open and you're kind of switching between them. Let's recap a bit. Do you want to click on the left side to show the left pane where we have all the Lattice things? Yeah, exactly. If you scroll down there, that's where we're sort of flipping between target groups and services here in Lattice. The target groups are the target group that Ryan is showing here is the one that was created by the ECS workflow. And now we've created the service in the services tab. So really straightforward. We haven't gone back and forth between EC2 and ECS and Lattice. We're just looking at these two separate tabs. Really important to learn something. We're doing all of these things in the console. However, we recommend everything to be automated. You shouldn't go into production and click off all of these things because they're really prone to human error. and it's much easier to automate them and get them up and running in a streamlined manner. So just take this as a learning experience and keep in mind that all things should be automated.
For context, I use the console about 5% of the time, and the rest is CLI. So yes, I can +1 to that, definitely.
That's great. Cool. Okay. So we have the service, we have the target group, the target health is active. The service is good to go?
Yeah, so as far as we're concerned, the service is up and running and we're good to go.
Let's look at
we can either test traffic on it now, or we can set up the Fargate one as well with other.
Let's first ask the super quick question in the chat. Can VPC Lattice be set up using CDK script?
Yeah,
Yes.
It's currently set up with for CDK level 1. The level 2 is in the works right now. I think we're planning on releasing an alpha version of it here shortly for customer feedback. Because usually we just want to see what customers like to see with those constructs. But yeah, you can get going with it now.
Awesome. And another old friend of our show, Robert Tables, CDK Love. So thank you, Robert. Thank you all for bearing with us today here and walking through together the demo of this really exciting new feature. Really simple from the user experience perspective, but Ryan here worked quite a lot on it to make it available. So we have the service ready. We have the target group ready for the service that is deployed on ECS based on EC2. So it's a self-managed ECS cluster. Let's do the Fargate one as well, and then you can share them with me, Ryan, and I can start testing some traffic.
Cool. Okay, so you'll see the flow for Fargate is very similar. So again, maybe important because I am jumping between tabs here. I am in the ECS console right now. So take a step back, you'll see this is the EC2 one, tasks running. This is the one we just set up. Now we'll go into the Fargate cluster. So I showed you before, but in here you can see the infrastructure is no longer the EC2 instances I spoke about, and it's instead configured with Fargate. But the process of connecting to Lattice is almost identical. So in here, we'll go and create the service. Again, we'll use the existing capacity provider that is Fargate. We will scroll down, same step as before. We'll select our task definition. In this case, we'll select the task definition I configured for Fargate. It is very similar and will also respond on port 80 just with HTTP. Service name, again, this can be anything, but for consistency's sake, we'll just keep it Fargate Lattice. Number of desired tasks, we'll keep 1. You'll notice here you don't actually need to specify your VPC because it is running on Fargate. A bit of a difference. Again, we'll come down to Lattice. This is identical to before. VPC here is pre-populated for you. Here we can choose the infrastructure role. You can choose whatever role you'd like. Again, you can also get granular with this. So maybe you do want a different role for every single target group. You're welcome to do that. You don't need to have the same infrastructure role manage each type for each target group you add.
Got it.
Okay.
This VPC here, what is its meaning? It doesn't mean anything, right? It's not used.
No. So this isn't the one this is the only VPC that I have in my account. This is the VPC that is configured in my task definition. So I specify a subnet in there and a security group, and those are related to this VPC.
Okay, cool.
Yeah, just keep in mind, even though Fargate is serverless, it still does require kind of like a VPC bucket, unlike Lambda. So Fargate's a little bit more kind of in that realm of where should I put an interface? What subnet does it live in? Things like that. You can do that with Lambda too, but Fargate requires it. It doesn't run like Lambda just out in the invisible world.
See, I created a few days ago my first ECS cluster based on EC2. I didn't get to create the one on Fargate, so My ignorance shows that I had no idea that you still needed a VPC for ECS Fargate. Now I know. Now I know.
Okay, and target groups here, again, we can name it whatever we like. We'll do Fargate ECS demo. Actually, because I want to match this exactly, we'll do Fargate Lattice, because I want it to look pretty. Okay, port name, again, this is taken straight from my task definition, test VPC Lattice. Port 80, and we are good to go. So we'll create this. While this is getting set up behind the scenes, we will swap back to the Lattice console here. We'll go back to our target groups. Cool, so the new Fargate one's already created. The task isn't registered yet, that's fine. We can go and create the listener for this target group. So we'll go back to the Services tab here. We'll go to Fargate. This one has a custom domain, so a bit different than ECS. You're welcome to bring your own domain. So just for the demo, we decided to try something different on this one. Otherwise, we will add a listener just like before. We will use HTTP. We will also use port 80 here. Default action will forward everything to the target group. So you can see the other one's already in use, so I can't select that, but I will select the Fargate one that I intend to forward traffic to, and we'll go add.
While this gets created, interesting. So if I have a set of targets, let's say I have an ECS service that I want to use in multiple Lattice services, I will need to create a different target group for each, right? And all target groups can point to the same task or ECS service definition, but I do need separate target groups, right?
Separate target groups if you're planning to go to separate Lattice services.
Yeah, exactly.
Yeah, that's correct.
Okay,
Just
perfect.
to restate that in a different way, if you have an ECS service up and running and it's doing a whole bunch of things, but it's one service, right? You have containers that are on different ports doing all kinds of different things. Those can be a part of multiple Lattice services if you want it to. You just have to create multiple target groups because a target group is tied to a service. So the target group can't be a part of a whole bunch of services. So same tasks, you don't need to duplicate your infrastructure or anything like that. It's just when you create that, you'll basically be assigning that ECS service to multiple target groups.
Perfect. Cool stuff.
Okay, and we can see this one's healthy as well, and it's ready for traffic. So I guess from the point of the ECS integration, this is kind of it. What we'll show you next is actually pre-existing to Lattice and sending traffic there.
Awesome stuff. We'll show you now the bane of the existence of networking people who don't understand applications, and why Lattice makes it so nice and easy for us. You can tell by the level of intelligence in the questions that I've asked today that I have no clue about ECS or ECS Fargate, but at least I'll be able to configure them and access them. So you'll see how easy that is. So
it is the
Ryan,
perfect thing, right? It's like the developer, whoever they are, right? Or cloud admin or whoever it is, they really are going to be the expert at whatever platform they use. You're going to have some of your team that's Lambda. You're going to have some of your team that's ECS. You're going to have some of your team that's EKS. The bigger the customer is, the more I see all platforms being used. Usually one team will kind of standardize on one platform, but even then it's like, okay, what if I'm migrating from ECS to Lambda or EC2 to ECS or to EKS, so on and so forth. It really does kind of make it better, right? Because the developer doesn't have to change to meet what the admin wants and is used to. Yeah. And the admin doesn't have to learn a bunch about ECS, EKS, Lambda, so on and so forth. You get both of them, right? Like they can stay in their own little guardrails, their own little boxes. And it's okay.
Thank you. Thank you. That's perfect. We have one quick question before we jump into the resource sharing part. Is it ready for IPv6? Does it work for IPv6? All of these things we've done here.
Yes.
Yeah, and there's some great blogs. I think, Alex, you wrote the blog on IPv6 with Lattice. This is one of the most powerful features and probably one of the most used patterns for why customers even come and look at Lattice in the first place. We also talked about it in our reInvent video last year. If you just search reInvent for Lattice, there's a talk about how it makes sense. But it's a great migration tool. Not only does it work with IPv6, but you can kind of mix and match. And so we're going to listen on IPv4 and IPv6. It doesn't matter what your backend target is. Doesn't matter what your client is. We'll do all the translations between it. You never have to expose that to the destination side or the client side. We do it all. So you connect to us on whatever IP you want. You have your service run on whatever IP you want, and we'll do all the middle magic.
Awesome. And I'll show you the curls today to show you how that works. And yeah, it'll be pretty fun. Let's see it.
Cool. Okay, so now I'll go over to Resource Access Manager. Some of you may refer to it as RAM. So this is what Justin was speaking about, which allows you to share resources. So previously I had shared the 2 Lattice services with Alex here, so you should still be able to see those in your account.
Do you want to take us through like the whole process of creating a resource share? Not the
Sure.
one that you already have.
Yeah, I can even remove this one if we like, or I can set up a new one here. So maybe you
can set up a new one called Twitch Live something.
Sure.
Just to preface, sorry to interrupt a million times. You don't need to do this if it is one account. This is only if you're sharing things across accounts.
Exactly.
Cool. So in RAM here, you have the option to share a variety of resources outside of Lattice. But if you choose to share Lattice resources, you will see 2 different options. So in this one, we can see the Lattice services that I created previously. So these are the 2 ones that are visible on the Lattice page here. If I were to go into them, you'd see the IDs match. So what this lets me do is select which resources I would like to share and then how I would like to share them. I will get all the way up to the end and then I will cancel this because they're already shared with you, but you can walk through the workflow.
You can actually create this a new
new one. Okay. Let me go back and let's delete this one and we can just do it fresh then. Okay, you've been kicked out of my services.
Perfect. That's great.
Okay.
I can't use them anymore.
Okay. Cool. Lattice services here. We'll select these 2. And these are the Lattice services here. We have the option to add tags. We will not add any today. Here you have the options for which permissions you'd like to grant the sharee in this case. So which permissions I want to give Alex. I'm going to stick with the default one. So she'll be able to create service network service associations and then do get service calls on these services. So she can see what the services, see a bit about them with a get call, and then she can add them to her own service network if she like to actually send traffic. So that's what she'll do next.
This is one of my favorite features, honestly. It launched recently with RAM. It's not maybe a year now, actually, but it makes IAM simpler. So you can control what either side is allowed to do on this thing, right? Is the person allowed to put it in their own service network? Are they allowed to take the service network and attach it to their VPC? These are all IAM actions that you can control through IAM. But if you're dealing with hundreds of accounts, even tens of accounts, dealing with IAM across these accounts could get difficult, right? So maybe you deal with it with SCPs, but it can still get hard. Customer managed permissions allows you to write what the permissions are on the resource itself before you share it out, right? And so you can then and there say, when I share this thing, that destination principal is only allowed to associate the service network to VPCs. They're not allowed to put new services in here, right? It's super powerful, super easy, and makes your policy so much simpler.
If
Awesome.
I can add one thing too, once you do share, if anyone's familiar with CloudTrail, any actions that are taken on these resources, either by the owner of the resources or by whom you shared them with, will be visible in the owner's account. So if Alex decides she wants to run wild and try to make a bunch of calls against the service, I, as the owner, can see that myself.
Cool. Awesome. We have 15 minutes left. Let's do this because I do really want to do a curl and
Okay.
see how it works.
Okay. So next step here, I'm going to share it with your account, which I have to the side here. Okay, so this is the principal I'm going to share those two Lattice resources with. We'll say next, resources to share, permissions we defined, and create resource share. So now on Alex's side, she can go into her console and accept those resource shares and then carry on.
Let me start sharing my screen and let's do this. Okay, perfect. So here I am in Resource Access Manager. I have shared with me resources, and I see, you folks see here that I have an invitation to Twitch demo resource share. So let's accept the resource share. I accept it, and now let's go back to resource shares. Perfect. I see it here. This is perfect. It's active. So if I go now to my service networks here in VPC Lattice services, I'll see the two services, Fargate ECS demo and EC2 ECS demo, that have been shared with me. One of them has custom domain name. This is great. And oh, you can see here the owner ID for these services. This is great. This hosted zone ID here is going to be really important for us to configure custom DNS. So what do I do now with these two services? From the admin perspective, right? Ryan manages the services. He's know what he's done there. I do need to provide connectivity to them, right, for my clients. So I have a service network already configured. It's called Twitch Service Network. It doesn't have any VPCs or services associated to it. It's like a default blank service network. No authentication enabled on it. You can always go back and enable auth policies if you wish to. So this is a really, really simple example of how to use this. So I go into service associations and I will create a service association, and I'll select these two awesome services that Ryan just shared with me and save changes. Let me do zoom in a bit. And oh, one of them is already ready. This is so fast, Justin and Ryan. Unexpected. Look, this is amazing. These are already ready, associated to my service network. Now, I don't have any clients associated to the service network, so any VPCs that can actually access these services. It's great though that I already have a VPC here that I created. This is a really simple VPC. You can see that it has both v4 and v6 on it. If you're wondering what this feature is here, block public access, we've just launched it a couple of days ago. Really highly recommend you go check it out. Really important for a tool or construct to allow you to secure your VPCs from internet traffic. I have a subnet here, a test subnet. It's a dual stack subnet, and I have in this VPC an awesome EC2 instance. I've navigated all this way to show you one thing, which is really important. I'm going to use EC2 Instance Connect to SSH into this instance, and I do not have a public IPv4 address here. Really important. You don't need public IPv4 addresses if you want to SSH into your EC2 instances. As long as they have IPv6 addresses and the right routing configured, you can go hop on EC2 Instance Connect. You can use this IPv6 address to SSH into your instance, and it works like a charm. So this will be my test instance here. I'll be using it to curl things. Back to my services here and my service network. My Twitch service network has 2 services associated, but I mentioned that I don't have any VPCs yet. So I'll just go here to VPC associations, create VPC association, add VPC association, select my awesome VPC, and configure a security group. You can add up to 5 security groups on this association. I'll just go to the default one. Not much security that I'm adding here, but really important. The security group helps you maintain that access control from within the VPC, who can access this service network. Anything I missed here, folks, before I save these changes? Really straightforward, right? Really, really easy, really simple. Now it's create in progress. While it's creating, actually, let's look at route tables for a second, because I think this is great. Not yet added. Just so you folks know, I do have my default route through the internet gateway, so my subnet is a public subnet. And I have the two local routes, one in v4 and one in v6. And once the service network association is done, you can see here that Lattice adds 2 routes to the route tables automatically. You don't have to worry about these routes. So many times I get the question of, well, how do I configure routing in my VPC, right? Back to those questions that network admins ask, right? We don't really care that that's an ECS service or it's an EKS service. We do care, though, about the routes in the route tables. So this is automatically populated. I didn't add anything to this route table. Lattice did all the work behind the scenes so that my instances or my clients in the VPC can access Lattice services. So let's see if it's done. Hopefully it is. Hopefully it is. If you folks have questions in the meantime, let us know in the chat. Happy to answer them. Oh, my VPC association is active. Let's see. Let's test our services now. I'm not gonna go through configuring the custom domain name. I'll just go directly with the domain name of the Lattice service. So just keep in mind, all Lattice services have an FQDN. You can use this FQDN anytime. It's pretty hard to remember, though. So if clients would need to use it, it would be like remembering an IPv6 address. Not doable. So that's why you would use custom domain names. We pasted in the chat the blog that shows you how to do this. But because we only have 7 minutes left, I'm just going to use the Lattice FQDN. So let me test this one out here. Oh, this is my old one. Let's see here. Curl -6. Ah! It works! It works! And for those of you who are asking yourselves, what is that -6? It's IPv6 and it works. And if I will do this. And
the IPv6 curl should be -4. Subtract v4.
Exactly. Cool stuff. So Fargate works, both v4 and v6. Let's see the other service that we have here. Services, EC2, domain name, curl.
Keep in mind that ECS service did nothing to move to IPv6 or anything. It's just a regular v4 service too.
I would say, and Ryan, hopefully you're not going to be upset. I don't think you intentionally ever intended to do IPv6 on your service. You're like, IPv6, what?
Yeah, I was a little scared when you put that. I was like, uh-oh, what's going on here?
Exactly. That's kind of the reaction of application people, folks, and service owners are like, why do I need to care about what that -6 is? I don't know. Lattice makes that super easy for you. So you see, it works both v4 and v6 depending on client capabilities. I get to choose what I access without having to let Ryan know, hey, I need you to support IPv6, Ryan, and Ryan asking me, well, what is IPv6? Really exciting. Cool stuff. Love it. This is so easy, so straightforward. Nothing weird here. Really, really straightforward. Now we are 5 minutes from time. I see here Robert sharing the fact that it's nice. It is really, really nice, really exciting. Looking forward to all the new things that you folks are still working on before reInvent.
I know we're gonna wrap up here and go straight back to work. We only got a couple more days before reInvent, so we've got some. We're really excited about a few more things we're working on. The other thing, I don't know, Alex, if you want to post, it is available in Terraform as well. If you're not a CDK user and you're a Terraform user, it's available there. Also CloudFormation. So whatever your flavor is, go play around with it in console and then do something different at scale.
Awesome. This is great. I've added in the chat the Terraform link. You folks can go back and review all the demo and play with it yourselves in your accounts. Just keep in mind, delete all the things if it's your personal account, so they don't end up being charged for. And just as a reminder, this is our last routing loop for this season. We are slowly getting into reInvent, Thanksgiving, reInvent, Christmas, Hanukkah, all the holidays in the holiday season. So really excited for this amazing year, folks. Thank you so much for joining us every Thursday here on the Routing Loop. And don't forget, we're going to be back in February, starting February 1st. We will probably start with a reInvent recap with all the things we've launched in 2024. So thank you again, everyone, for having joined us throughout this amazing year with a lot of cool things, a lot of cool launches, and a lot of cool demos. Any closing thoughts, Justin, Ryan?
I don't think so. I think I'm excited to see everybody, and stay tuned because there's quite a lot going on right now, and it's not much time until we start talking about it. So
Awesome.
Stay tuned.
Well, thank you. Thank you both for the awesome demo. And thank you, Ryan, for bearing with my noob networking questions. And looking forward to meeting you all at reInvent and in 2025. Have an awesome holiday season, folks.
Happy holidays, folks.
Thank you.